Hello friends, welcome to C# Intermediate to Advanced tutorial. Now you are watching a final part of the subseries 11, Semaphores. So in this video we will implement Semaphore so that only 4 threads will be allowed to access a shared resource. The shared resource here in this example is a arraylist. Alright, now we will proceed with the example. Here if you see, we include the namespace for threading as well as a collection. So first we create a array list, then we create a random number instance, then we create a semaphore instance. Okay, here we haven't created the semaphore instance, we just declared it. Then inside the main entry point we run a loop. It will run for 100 times and makes a call to random number next 99. So this 99 tells give me a number between 0 to 99. So a random number between 0 to 99 will get added to the array list slot, and since it is running for 100 times, there will be 100 slot and you will be seeing some random numbers in each slot. Next, here we are creating the semaphore. The first parameter here tells initial number of threads allowed, and this is the maximum number of thread. So here we are stating that we will allow maximum of 4 thread. Next, here we create 100 threads and starting it. So we have seen this many times in the threading series. We create a thread start delegate, we pass get 5 rand proc. So get 5 random number procedure. Okay, so this is the thread we are creating. We are passing the thread start delegate, and that delegate points to the function get 5 rand proc. Then we are giving a name for the thread and starting it. After that, we just print a message stating main thread gives 3 seconds for starting all threads. All thread means all these 100 threads. So we give just 3 seconds, that's enough to start. Why? Because we already made call to start. So 3 seconds is huge enough for these threads to enter this procedure. Next, in the console we are stating main thread releases 4 thread to enter. So main thread means this is the main thread. This will be our main thread. It allows 4 thread to enter. That means it will make use of the semaphore. See here, semaphore dot release 4. That means we are asking to release 4 thread. So by this time there will be a queue of 100 thread. Why? Because here we created thread T1 to T100, right? And we are giving enough sleep time also. So by this time all thread is waiting on the wait one method of this method. So this method uses the semaphore, and yeah, once we go to that method, that time you will know. And here 2 second delay we are giving, right? There are first we are giving a 3 second delay so that all thread will go to the concerned thread procedure. then we are giving 2 more second delay, and we are releasing 4th thread. Yeah, here if you see, initially we are not allowing any thread. So initial thread count we are setting it as a 0, and we are not allowing any thread, and maximum we specify 4. So initial is 0. Once we release 4 thread will be allowed. After that a maximum of 4 will be maintained. So this parameter, second parameter I am talking about. Alright, so after releasing 4 thread, main thread sleeps for 15 seconds. So here we are not using any thread.join, and so it's simply a time based calculation. We are giving a 15 second, and based on this procedure, it was already calculated for this demo. All thread will finish within 15 seconds. So we are waiting the main thread for 15 seconds. Finally, we print a message stating main thread quits. So there are stuff that you need to note here is A. We are creating a semaphore. We state the initial thread allowed is 0, maximum is 4. With these 2 parameters we created the semaphore. Random number was already ready with the array list of 100. Then we start 100 threads. Main thread is waiting for all thread to start. Then we release 4 thread. Then main thread waits for 15 seconds. So here is our get 5 RAND procedure, and here we are getting the thread name. Thread name was already assigned here. This just for printing purpose, so that you will come to know which thread is accessing the resource. So console.writeLine thread name started, then the thread will run for 5 times. So here let's state thread T1 is accessing it. Likewise there will be 100 thread. Okay, so T1 is accessing it. It will print thread or T1 started. After that it will run for 5 times. That means there will be a loop. Inside the loop we state thread name, that means T1 waits. From semaphore we are making call to wait 1. So here, since we are allowing 4 thread, this wait 1 will allow 4 thread. So it keeps track of how many thread is using the shared resource. Shared resource here is the array list. So if there are 4 thread already using it, the call will get blocked. Or if there is only 3 thread, then 1 will be allowed. So whoever is climbing, there will be a competition and racing condition. 1 will be allowed to enter inside, and the semaphore count reaches to 4. Any other thread who is climbing the wait 1 should wait. Alright, so once the thread enters, now let's assume that T1 entered inside. It reads a number. When it is reading the number, R&D number is our array list, R&D number, and if you see inside the indexing, we once again specify the, so it can read any element and print it in the console window. Alright, thread name, read number, and it is printing whatever number is read by the thread. So there is a 20 seconds delay. It releases the semaphore. Here if you see, when wait 1 is allowed to enter inside, there will be an increment, and whenever there is a call, there will be a decrement. Thereby the thread count will be tracked. Finally, once we read all 5 elements, we state thread name quits. Alright, now we will go to the demo. We will create a console application. Semaphore demo. As already explained in the slide, we will include the required namespace, threading and collection. Then as a class member, we will create 3 static members. One is arraylist, another one is random. This is to generate the random number. Then we have a semaphore instance. So inside the main method, we create 100 random numbers. Then we create instance of semaphore. We will change parameter when we are running this sample. Then we create 100 threads and starting it. So it's showing error. Why? Because we haven't yet defined this thread procedure. Alright, so these are all already explained in the slide. So next there will be a static method. Now we will build this solution. We will copy the path. So the path was copied and we already moved to this folder, and we will run the exe. So main thread will wait for 15 seconds, and before that we will examine the output. Okay, here you are seeing main thread quits. Initially, if you see, T1 started, T1 waits, T4 started, T5 started. So you will be seeing a lot of started and wait message. So it's because of the 3-second delay main method is giving, and you'll be seeing up to T100. T99 started, T99 waits. Here you are seeing main thread gives 3 seconds for starting all thread. So only T100 took the advantage of that 3-second delay. All other threads are already started within that fraction of second. After that, if you see, main thread releases 4 thread to enter, and you can see 4 thread is reading the random number, right? The threads are T4, T1, T3 and T5. Since only 4 thread is allowed, Here you can see other threads are waiting. Here you can see T7 and T11 enters, then T3, T4 and T5. T3, T4, T5 all goes into wait stage, so other threads are allowed to enter, right? So since we allowed maximum of 4 thread, here you can see an example. Here 4 thread is reading the number, here 3 thread is reading the number, right? Now we will change the example so that more number of thread is allowed. So can read the syntax or the parameter. The first one is initial count. We are allowing only 0 thread. Later we are making call to release. That means we are allowing 4 thread. So initially we doesn't allow any thread to enter. And maximum count, if you see, we allowed only 4, and we saw that also in the example. Now we will increase this, as already told here, 20. You can give any number, even you can put 10, 15, whatever you want, but definitely now you will be seeing more than 4 thread is using the shared resource. Why? Because maximum number of thread allowed is 20. Now we will rebuild the solution and we will run it. So there will be a 15-second delay for the main thread. Now let's examine the output. 2, 3, here it is 4. I'm looking for somewhere it is reading 4 or 5 thread. Reading the array is not happening here. Alright, now let's try to reduce the sleep here. Here we can change the sleep, or we can allow, yeah, here also it was already specified. Here also it was already specified, revisit snippet 7. Here we are releasing only 4, right, initially. Either we can adjust that sleep, or here we can allow 20 thread initially, or 40 thread, whatever. Now we will rebuild the solution. We will run it again. So towards the end of this random number read, if you see, you may not be seeing more number of thread, and when you go in top, since all these thread quits, there will be less number of crowd. When crowd is more, that time there is a possibility of, here you can see, it's a possibility of seeing more than 4 thread. Here you can see almost 6 thread is reading the shared resource. 5. Here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10 threads are reading the content. 4. So now you got the concept how Semaphore works. That's all here in this video, and we came to an end of threading series, and in the next video we will see how to create a service using C#, and we will end the C# intermediate to advanced tutorial. Thank you for watching. Bye.